So I will try to finish the discussion of the transfer functions in such a way everyone going back and feel comfortable to finish this homework. So the transfer functions we have done and last time quickly is that showing you a quick way to apply the Laplace transform to these generic equations, and then to show how to obtain the transfer functions. And today I'm going to use one real example with the numbers and to show the whole process, and in the meantime along with the demonstration of the slides. Okay. And so from here you can see in this example I use this kind of notation. Basically this is a complex number. If we expand it, basically containing this is equal to cosine omega t plus j sine omega t. So basically here in this way, that is the only way allow us to combine the cosine and sine together. We simply taking advantage of the complex algebra. Okay, so here, by doing so, that means we introduce the j, and so that's saying in this slide later we're going to have the quick illustrations of the simple complex algebra. We're going to base on that one to do something. And before we proceed, and here kind of introducing a few terminologies. Sorry, I covered this one. Terminologies for communications. Okay. So basically, transfer functions take this kind of graphical representations, and this is a transfer function, this is the input, and this is the output. And in algebraic way is output y equal to transfer function multiplied with input. For example, 4 equal to 4, 4 equal to 2 plus 2, 2 minus 2 times 2. For example, 6 equal to 3 times 2. This kind of concept. In this way, y equal to g times x. So that is a graphical representation of kind of the input-output relations. Okay. So here we call the input or excitation. Basically, here for our vibration, this is the excitation. That is a force, and output or response. Basically, that is our degree of freedoms. And transfer functions basically is a relation between the output to input, so y over x. And for this example, say here the degree of freedom is y, that is response. So response is output. And subject to the applied loading, the loading is input. So basically in this way, if we take the Laplace transform and from the skip the skills we take last time, basically we replace the double derivative with s squared, and first derivative with s, and this one with the constant. So basically we have this kind of relations. Okay. Zeros and poles, those things we won't be used. We rarely use the two terms in vibrations. But basically zero meaning the poles basically is the root of the denominator's polynomial. Okay. And zeros means the root of the numerator's polynomial, which is constant for this case. Okay, the two terms will be used in system dynamics like control. But anyhow, the characteristic equations, and we see this term quite often. Basically, that's saying is we're setting the denominator polynomial equal to 0, and that equation called the characteristic equations. Okay, so basically here the unified terms we're going to use. And so in MATLAB, we can build up the representation of the transfer functions by such. For example, if we have a transfer functions, this is the numerator polynomial and denominator polynomial. You can simply describe the numerator polynomial in the descending order in the degrees. So for example, here is the highest degree, and the first degree, 0 degrees. So you replace the coefficients in the descending orders, and 2, 1, 1. Just you separate by a space or by a comma, either way. Okay. So you put into this and you name it, and this is you can give it any name. So that meaning the numerators and denominator the same thing. You start from the descending order 1, 2, 3, 4, separated by a space or by a comma. And then you simply using TF TF means the transfer functions. Okay, and the TF will take out the information you put here, and in the computers, it's going to memorize this particular transfer functions in this one, and that is the name you give up it by yourself. Okay, and you can have any name you like it. And so under this case, once you type in, you hit the return here. If you know the semicolon is to suppress the display of the whatever result. And here I don't put the semicolon. Basically, once you hit the return, right away, after you hit the return, then you will see some kind of graphical, not graphical, the display kind of the transfer functions on the screen. You will see. Okay, give a try. And then TF data, I forgot this command. So give a try. I forgot this one, but so far so good. Okay. So that's the way we can use MATLAB to work with transfer function, but I won't use this one a lot in vibrations, but we're going to have quite a bit in controls. Okay. So let us do some summaries, which means we can work on the slides and on the board for examples like this. Okay. And if you have a handout, I give to you Monday so that we can have the